In order to solve this question number 435, this question, that force F has been applied on the curved chord AB. This is rope AB, this is curved. We're applying force F and we have to determine how much is the smallest value, how much smallest value of F we can apply on this rope AB so that this rope fails at point A, and the maximum moment this rope can withstand at point A is 1500 Newton. Okay, so let's do one thing. Let's draw the radius vector from point A to point B. Okay, so this radius vector, we can write this as, this is radius vector R. It has been drawn from point A to point B. We'll write this as RAB. Okay, this is our radius vector RAB. Now, this is force F which has been applied in this direction. There are various ways of finding this radius vector RAB. One method of finding this radius vector RAB is using the triangle law of vectors. The triangle law of vectors, we can draw the triangles. We can say, let's draw from this point, let's draw one vector in this direction. Okay, and from here, let's draw another vector in this direction. Okay, using the triangle law of vectors, we can find the value of RAB. That's one way of doing it, but that will be a bit tedious in this case, because as far as RAB is concerned, this RAB in this triangle law, it does not come along is not a vector which is actually the resultant of other two vectors, because if you use triangle law of vectors, you have to add this vector with this vector and this will be the resultant. Okay, so using triangle law of vectors, using this law, you will obtain this vector, not this vector. Okay, so what we'll be doing, we'll use the concepts what you call as, what we have been calling as, the using the distance formula. As far as this point A is concerned, the coordinates of point A are, point A is along z axis, it's on the z axis, it does not have an x coordinate, it does not have a y coordinate, so its x is 0, its y is 0. As far as this z coordinate is concerned, the z coordinate is 4 meter. Okay, so these are the coordinates of our point A. Now, as far as point B is concerned, let's write down the coordinates of point B. The coordinates of point B are, in order to reach to the point B along x-axis, we have to describe this much amount of distance. Okay, this much distance we have to describe, and this distance is equal to this total angle is 90 degree, this angle is 45, therefore this angle is also 45. Or we have to find the coordinate of point B. The coordinate of point B along x-axis is equal to this much distance. Okay, and since this radius, this distance from this point to this distance is 4, therefore this distance will be equal to 4 sine of 45 degree, this distance. Okay, this distance is, that is the distance from here to here is 4 sine 45, because this is 4, this angle is 45, this distance from here to here will be 4 cos of 45, and this distance will be 4 sine of 45. So its x coordinate is equal to 4 sine 45. Its x coordinate of point B is 4 sine of 45. This is the x coordinate. Now look at its y coordinate. The y coordinate of point B, the point B lies on xz plane. The point B is here. Okay, it does not have a y coordinate. Its y coordinate is 0. Okay, because point B is lying on xz plane. This point B is here. It does not have a y coordinate. Now, as far as z coordinate of point B is concerned, we have to go from here to here. In order to reach to point B, we have to describe this much amount of distance. Okay, this distance we have to describe. This distance is 4 meter. This angle is 45. Therefore, we can resolve this 4 meter. We can say that this distance is equal to this distance, which is equal to 4 cos of 45. So this is 4 cos of 45 degree. This is 4 cos of 45. Okay, so this is our, these are the coordinates. 4 sine 45, 0, and 4 cos 45 are the coordinates of point B. Okay, so after writing the coordinates of point B, what we will write, After writing the coordinates of point B, we can directly write now, therefore, position vector RAB, position vector RAB is equal to, position vector RAB is equal to, it's equal to, you are drawing a vector from A to B like this. So the vector will be uh, x coordinate of point B minus x coordinate of point A along x-axis. X coordinate of point B is 4 sine 45. That is 4 by under root 2 minus x coordinate of point A, that is 0. Okay, that is 4 along x-axis. Y coordinate will be y coordinate of point B minus y coordinate of point A. The y coordinate of point B is 0. Y coordinate of point A is 0. 0 minus 0 is 0. Okay, so second coordinate is 0 along j cap. And the third coordinate is the z coordinate of point B minus the z coordinate of point A. The z coordinate of point B is 4 cos 45. That is 4 cos 45. That is 4 cos 45. That is 4 by under root 2 minus the z coordinate of point A, that is 4. That is 4 by under root 2 minus 4 along z axis k cap. So this represents our vector. This is our vector RAB. Okay, so our RAB is 4 sine 45 I cap, 0 along j cap, 4 cos 45 minus 4 along k cap, which is equal to, which can be written as, this is 4 by under root 2. 4 by under root 2 is equal to, if you divide 4 by under root 2, it is equal to 2.828. So this is 2. This is 2.828, 2.828 I cap plus 0 j cap plus, this is 4 by under root 2 minus 4. 4 by under root 2 is 0.28 to 0.828 minus 4. That's equal to 1.1716. That is, but minus. So this is minus, this term is minus 1.1716 along k cap. This is 1.1716 k cap. So these are the components. This is our radius vector RAB. Okay, so we have obtained the radius vector RAB, and our radius vector RAB is having this as x component and this as its k component. Save this RAB. Now after drawing this RAB, we have to find this force F. Look at this force F again. Force F we have to find, but this force F, its magnitude we have to find, but the direction of force F is given to us. It's acting from point B to point C. Now using the distance formula, you can write force F in terms of its magnitude F and the unit vector drawn from point B to point C. Now, in order to find the unit vector drawn from point B to point C using the distance formula, you should be knowing the coordinates of point B, which we already know, and we should be knowing the coordinates of point C, which we can easily find. The coordinates of point C are along x-axis. Along x-axis, point C is at a distance of 6 meters. So this is 6 meters along x-axis, comma. As far as along y-axis is concerned, the point C along x-axis, along y-axis is also at a distance of 6 meters.